Okay, my dear students, let us start with where we left in the previous class. Okay, so I was just talking about the powder metallurgy process. So in the previous classes, we were talking with respect to the powder metallurgy and the definition of powder metallurgy, merits, demerits, and all those things. So the next thing is the powder metallurgy processing. So how you can manufacture the products using powder metallurgy technique. So generally three processes, three different processing steps we are having here. Powder, and powder needs to be processed, and then we have to check it for the properties. So the powder in the sense, so here we need to have a powder fabrication, size and shape characterization, microstructure, and chemical homogeneity and particle size. Here, see, as we were discussing in the previous slides, the powder metallurgy technique is relatively expensive because of it involves an additional step where the powders needs to be manufactured from the materials or metals. So that is one important step in the powder metallurgy processing where a powder needs to be fabricated. And next thing is we need to characterize the size and shape of the powder particles, and we may need to check the microstructures and the chemical homogeneity. So once the powder has been manufactured and it has been tested for its chemical homogeneity or microstructure or shape and size, then it needs to be processed. So processing will be done either by compaction, sintering, and forging and hot pressing. These are the different processing steps what we are having in powder metallurgy. Next comes, we need to test it for the properties. So whether that part will have a density, required density or porosity, whether it possesses required ductility, strength, conductivity, or any other functional properties. So this is actually the process of powder metallurgy. It is not that only we can manufacture the powder or fabricate the powder and then process it and it will going to get the properties. I mean, sorry, products. But here, once the powder has been fabricated, we need to test or we need to check or we need to measure what is its size and shape and what is the microstructure and the chemical homogeneity. This is very important thing. And after processing the powder with the compaction, sintering and forging, then we need to check the products for its required functional properties, whether it can attain required density or porosity or ductility. This is where the powder metallurgy stands ahead of all other processing, manufacturing processing techniques. Yeah, this is consisting of certain processes, powder metallurgy. So here, the powder metal powders are made, and then we need to get additives, so dilubricants and graphite. Okay, so metal powders. After metal powders are manufactured, then additives or binders, what we call it as, just like a dilubricants and graphites. So those two will be mixed, what we generally call it as a blending. So we need to ensure that both metal powders and the additives gets binded together or blended together properly. That is what we call it as mixing. Next comes compacting. So we're going to press the powder to a required mold or required die we have, and then we're going to heat it, to heat the component for less than its melting temperature, and then the secondary operations if anything required, and we're going to get the final. This is basically the powder metallurgy process. And this is a complete elaboration of this process, what we have shown over here. Okay. So again, if you look at here, so this is a flow diagram. Actually, we have shown here a flow diagram of powder metallurgy process. So where we are having, look at here, the atomization and the metal powders. So metal powders can be manufactured or it has been fabricated by different methods. So these are the powder metallurgy fabrication techniques here: atomization, reduction, electrolytic deposition, carbonyls, comminution, mechanical alloying. Any of these methods we can use and we can manufacture the metal powders. Once the metal powders are manufactured, it needs to be added with the binders, additives, lubricants. Okay, once it is added, it needs to be blended. It needs to be mixed properly, the suitable blending machines. And then next comes the two important compaction. Either it is a cold compaction or a hot compaction, depending upon what kind of material you are using, the powder metal you are using. So whether it is cold compaction is required, pressing, isostatic pressing, rolling, extrusion, injection molding, all this corresponds comes under cold compaction, and only hot compaction is the isostatic pressing. So when you have a hot compaction, there will be no requirement of a sintering process. So when you have only a cold compaction, look at here. When you look at here, when it has been cold compacted, sintering through atmospheric or vacuum, so you go into sinter it, means you go to heat it, the metal powders less than its melting temperature. And once it, or if it is hot compaction has been done, no question of sintering, directly it will go to the secondary and finishing operation. So this is basically the flow diagram of complete powder metallurgy process. So of course, the secondary and finishing operations might be in the form of a coining or forging or machining or heat treating like that. There are so many secondary and finishing operations we are working. So this will gives a complete picture of how the powder metallurgy process will be going to take. Okay. Now let us start with the first one. The first step in the powder metallurgy process is production of metal powders. So this is one of the step which makes the powder metallurgy process or powder metallurgy technique as an expensive. And we have a quite number of techniques involved. We have to produce these powders, metal powders. Okay. So what are those powder techniques we are having? How we can produce the metal powders? Okay. So what are the principles behind this different techniques? We will going to discuss one by one. Okay. Let us start with the powder production techniques. The powder production techniques basically we categorize into three headings. One is the mechanical method of powder production. Second one, chemical methods of powder production. And third one, physical methods of powder production. So these are the three different methods what we are discussing over here. Of course, they are specified in the syllabus. So we need to discuss three different methods. One is the mechanical methods of the production, chemical method, and also physical method. Okay. Let us look at the one by one. For mechanical methods of powder productions, we have chopping or cutting, abrasion methods, machining methods, milling, and cold stream. So these are a few mechanical methods in which you can produce the powders. First, we'll discuss some of these different methods. And second one is chemical methods, reduction of oxides, precipitation from solution, thermal decomposition of compounds, hydrate decomposition, thermite reaction, electrochemical methods. Like that, there are quite number of ways in which you can fabricate or you can obtain the metal powders by using chemical methods. And the third category is the physical methods. So we have three different, that is what we call it as an atomization. Okay. So three different ways in which you can get powders by physical methods. One is called water atomization, second one is called gas atomization, and third one is called special atomization. See, you can produce the powder by any one of these methods, not an issue. But only the choice of specific technique for powder production depends upon the particle size, shape, microstructure, and chemistry of powder, and also finally cost of the powder. So these are the parameters that needs to be taken care while you are making the choice for a specific technique of powder production. Okay, one is the particle size. What should be the size of the particle we need to have, and what should be the shape, and what the microstructure that powder is supposed to have, and the chemistry of the powder, how it can combine combine, how it can react, how it can blend. So there are so many aspects when it comes to the chemistry, and ultimately the cost. Cost is also very important. So these are the parameters that needs to be taken into consideration while you are choosing the uh, specific choice of any one of these. Okay? Let us start with the first case now. Mechanical methods of powder production. Mechanical methods of powder production. So here we have uh, first method, what we call it as a chopping or cutting. In this process, strands of hard steel wire in diameter as small as 0.01313 inches are cut up into small pieces by means of a milling cutter. This technique is usually employed in the manufacture of cut wire shorts, which are used for peening or short peening. Chopping, just to chop it off or cutting. So what we use here is the strands of hard steel wire in diameter as small as 0.0313 inches are cut up into small pieces by means of a milling cutter. Milling cutter is cut small pieces, and this technique is actually employed in the manufacture of cut wire shorts, which are used for cleaning or short. See, one of the major limitations of this is it would be difficult and costly to make powders by this method, and for this reason, it is not profitable to discuss the technique. So we are not discussing this technique in detail because chopping and cutting is relatively an expensive, okay, and difficult too. Second one is rubbing or abrasion methods. These are all the sorts of ways in which a mass of metal might be attacked by some form of abrasion. So there are two ways here. One is rubbing of two surfaces. When we rub two surfaces against each other, hard surface removes the material from the surface of the soft material. So this is one different method. So the problem with this kind of method is a contamination. Means it might have some other waste products or impurities that might be uh, present in the powder what is going to manufactured by this kind of method. So rubbing in the sense, so when we rub a hard material with a soft material, so two different materials having different hardness. The hardest material, when we rub both the things, the hardest surfaces will remove the material from the soft material. This is quite natural, everybody knows. But only the problem with this kind of method is contamination. That is just what I was talking about. The impurities or unwanted materials might be present in that powder which we form. Second method is filing. Filing is a production method has been frequently employed, especially to alloy powders when when supplies from conventional sources have been unobtainable. Such methods are also used for manufacture of coarse powders of dental alloys. Filing can also be used to produce finer powder if its speeds are very small. And major problem is commercially not feasible. Here, filing. So you might have done filing in your workshop. So the same method over here. So alloy powders, you can, when you file it, so you will going to get the small powders, the small unwanted materials, and once you just filing it a mild steel material in your workshop. So small powders that will going to form. This is another method what we are talking about filing. When conventional sources have been unobtainable, when you don't get a conventional method, so this is the one method they can use. And the size and the shape of the powders, what you are going to get, it is like a coarse. It is not a very fine powders you are going to get. It is a coarse size you are going to get it, which powders of dental alloys. And filing can also be used to produce fine powders if the teeth are very small. If you have files which are having a very smaller teeth, then they can produce the final powders. But this kind of method is commercially not feasible. Therefore, we will not discuss in detail. Next comes scratching. If a hard pin is rubbed on some soft metal, the powder flakes are produced. Scratching is a technique actually used on a large scale for the preparation of coarse magnesium powders. So here is another one method called scratching. So you can understand the meaning of the word scratching. When a hard pin is rubbed on some soft metal, so you will going to get a flake-like powders. Flake powders are produced, and this kind of method is used on a larger scale for preparation of coarse magnetic powder. Scratching a slab of magnesium with a hardened steel pin and revolving a metal drum to the surface of which is fixed a scratching wheel. The drum, which is about 8 inches in diameter, rotates at a peripheral speed of approximately 250 feet per minute. The slab of magnesium metal, 14 inches wide by 1.5 inches thick, enters through a gland in the drum casing and presses against the. This is what they are talking about. So the process of scratching generally uh, used for revolving metal drum to the surface which fixed the scratching belt. So belt drum will be there, which is having 8 inches diameter, and this drum will start rotating. It can rotate at approximately around 250 feet per minute. And the slab of magnesium metal. So when a slab of magnesium metal by 14 inches wide and 1.5 inches thick enters through a gland in the drum casing and presses against the skin. This drum will go and press this magnesium metal against the pin, and then you will go to get the metal powder flakes by means of scratching. One method what they were talking about to call it as scratching. Okay. Next comes machining. A machining process using, for example, a lathe or a milling cutter in which something more than just a scratching is involved. Since the attacking tool actually digs under the surface of the metal and tears it up. On a lathe machine, by applying a small force, we get a fine chips. A large amount of machining scrap is produced in machining operation. This scrap in the form of chips and turnings can be further reduced by size in weight. So this is a very simple technique. You might have been done these things in your machine shop. Okay. So where example we can have a lathe or a milling cutter. Okay. So that tool, cutting tool, whether it is a drill tool or lathe tool or a milling cutter, which digs the surface of the metal and it tears of the just like in the form of refined chips you go to get it. And a large amount of machining scrap is produced by machining operation. This scrap in the form of chips and turnings can be further reduced by size by because you just grind it, these chips, so you are going to get the powders. But this kind of method is suitable for small scale production. Okay, a very simple technique machining is. And the disadvantages over here is the lack of control on powder characteristics, including chemical contamination such as oxidation, oil, and other metal impurities. The shape of the powder is irregular and coarse, especially in the case of a machine. So you cannot have control over the powder characteristics, which may include chemical contamination in the form of an oxides or an oils, or even some other metal impurities might be impregnated over there. So one thing you cannot have a control, and also you cannot have a regular shape of the powders. Shape of the powder is irregular and coarse. So sometimes the coarse powders may not be useful for making certain specific products. In such cases, this method is not suitable for producing the powders. So therefore, The major disadvantage of this method is lack of control over the powder characteristics and the shapes. The powder shapes will be irregular and coarse. And of course, apart from that, we have certain advantages here. For consuming a scrap from another process, machining is a useful process. Presently, the machined powder is used with high carbon steel and some dental amalgam powder. See, instead of making those chips which are resulting from either turning or milling or drilling, whatever it might be, and it will be treated as a scrap. But when we use that scrap for making a powder, which can be used in powder metallurgy technique to make a product, then definitely machining is a useful process because you can minimize the wastage of material from the metal removal process by converting the scrap into an useful powder for powder metallurgy. Presently, the machined powder is used with the high carbon steel and some dental amalgam powders. So this is a generally presently we are using this. These are the methods useful for high production rate. Best examples of mechanical production methods are milling process and cold steam. Yeah, let us discuss this milling. The basic principle of milling process is the application of impact and shear forces between the two materials, a hard and soft, causing soft material to be ground into the fine particles. So you know what is milling. I don't want to discuss the milling process here. So milling techniques are suitable for brittle material. This is very important. Here, milling is best suitable for making the powders from brittle material. And there are two types of milling here. One is called ball milling, other one is called attrition milling. Okay. What are those things? We'll discuss. So ball milling. A ball milling is an old and relatively simple method for grinding large lumps of materials into the smaller pieces and powder form. One of the oldest method of obtaining the powders is the ball milling. So we have two balls to which we're going to just pass the metal and it gets converted into powder. Method of grinding large lumps of materials into a small pieces and powder form. Look at that. Okay. Principle of the process. The principle is simple and is based on the impact and the shear forces. Hard balls are used for mechanical combination of the brittle materials and producing powder. So as already we discussed, the process, the milling process is basically the production of powders by milling is suitable for brittle materials. So once the material has been passed through the two balls, hard balls, okay, so mechanical comminution of the brittle materials and happens and it is going to produce the powders. So you look at the milling unit over here. The basic apparatus consisting of the following: a ball mill or a jar mill, which mainly consists of a rotating drum lined from inside with the hard material. Hard balls as a grinding medium, which continue to impact the material inside the drum as it rotates or a ball mill or a jar mill, which mainly consists of rotating drum lined from inside with the hard material. You can see here. So this is a drum, and it is inside. It is lined with a very hard material. Very hard material. Okay. Hard balls as grinding medium, which continue to impact the material inside the drum as it rolls or rotates. Here we are having the hard balls. You can see these hard balls over here. Okay. So as the drum rotates, okay, so the yellow color will be the material, and these are called the hard balls. And the inside the drum is also you will be having a hard material. So what happens when this drum rotates? These balls will have an impact. It will impact these materials, And because of mechanical combustion, because these are all brittle materials, when two or three balls will commute with respect to the material will get grinded up. That's why it is called the grinder, the medium of grinding. So it will get grinded and it will going to produce the powder. Very simple technique and very old technique of producing the powders in this method. Okay? So this is just a schematic representation. This is a picture of ball milling. Okay. So here we have ball milling. You can see the drum, outside drum. Inside you will have hard balls, which act as a grinding media. And when you load the material and when you rotate it, okay. So these balls, hard balls will impact and it will produce convert that material into a. The important parameters that needs to be considered here is the speed of rotation of the drum. Is the most important. The first important parameter is the speed of rotation of the drum. An optimum or critical speed is adjusted for maximum impact velocity. This is very important. So at what speed you are going to rotate the drum so that the hard balls will go into impinge or it will go into impact the material to obtain the powder, the material powder. So we have to know what is the optimum speed. You cannot run at the over speed or you cannot run at the slowest speed. So both will have different effects over the production of powders. Okay. So therefore, the speed, what we generally call it as an optimum or a critical speed. Once you adjust it for optimum speed, so then you will have the hard balls will have impact with their maximum velocity, maximum impact velocity. So therefore, the critical speed is the speed above which the ball will centrifuging. Very slow speeds of rotation will not carry the balls to the top. These will roll back to the drum slides. This is very important. That's what I was talking about. The speed of the rotation of the drum, it should be optimum speed. If it is very slow speed, the ball does not move to the top and the ball will roll down back to the drum sides. If it is rotating at the highest speed, that is more than the critical speed, the ball will not come to the bottom side as they will be carried due to the centrifugal force. Thus, an optimum speed is required. This speed of rotation varies with the inverse square root of the drum diameter. This is very important. So, size of the drum is varies inversely with the square root of the drum diameter. That is, means the speed of rotation. Speed of rotation varies with the inverse square root of the drum diameter. This is also important here. Okay. Then the second thing here is the material of the grinding. The material of the grinding media and its size, density. The grinding media, what type of grinding media we are having and what is its density. These two are the important things for us. The material of grinding media and its size and density. The size and density of the milling medium is selected according to the deformation and the fracture resistance of the material. The milling media, the hard balls, what you are getting here, that should be selected according to the deformation and the fracture resistance of the metal. So which type of material powder you are making of? So what is its fracture resistance and what is the deformation? That will be counted, that will be considered while you are selecting the milling media, means the balls. The hard and brittle materials, large and dense media is used, whereas small balls are used for finer. As a general rule, The balls should be small and their surface should be little rough. The material of the balls and lining of the drum should be same as that of the material being rough. In a sense, one important thing, the general rule what you're supposed to follow for any kind of media is the ball should be small and its outer surface should be little rough. The material of the balls and lining of the drum should be as same as that of the material being round. So this is another important thing here. What type of material you are using for making the powder? The same material you have to use it for the balls and also for the lining of the drum. So these two things are important. Then the third important point to be considered here is the rate of milling of powder is a function of the quantity in the total space between the balls. So how fast the powders are produced? That is what we generally term it as the rate of milling powder. Means how fast and what and how much time, how much amount of the powder has been formed. We generally term it as a rate of milling. Basically, this rate of milling of a powder is a function of a quantity in the total space between the balls. How much space between the balls is there is the factor function for the rate of milling. And the lubricants and surface active agents are used to nullify the welding process which causes agglomeration. So these are the four important points that needs to be considered while you are making the ball milling process. And the grinding mechanism here is during milling, the following forces will cause the fracture of the material into a powder: impact forces and shear forces. These impact forces are caused by instantaneous striking of one object with other. Impact is the instantaneous striking of one object by the other. Both objects may be moving or one may be stationary. This is the impact force means the huge amount of huge magnitude of force applied within a very short interval of time. So instantaneously one object strikes the other. So maybe both are moving or maybe one is stationary and one is moving. So then the force what it will go into apply is considered as an impact. So impact force is one of the force which causes the grinding mechanism. And second one, the shear forces. These are caused by one material slides or rubs against each other. So shear means it is a tangential force. So if one surface moves over the other surface, okay, then generally across the surface you will find a force what we call it as the shear force. So these are the two forces, impact force and shear force, which causes the fracture of material into the form. This is the basic technology behind converting the material into a powder form. The limitation of this ball milling, rubbing action causes contamination of powder since balls may also get rubbed. So another one important. So apart from the material getting rubbed with the hard balls, sometimes the two balls may get rubbed off. So we may find some contamination. Working hardening of metal powder is caused by during milling. Work hardening, I'm sorry, it is not working hardening, it is work hardening of metal powders. Metal powders may be strained more. There is a possibility of excessive oxidation of metal powders. Quality of powder might be poor, and particle welding and agglomeration may take place. So because of very fine powders, the particles gets welded up and they form an agglomeration. So these are the limitations of this kind of process. Now let us move on to the next process is the cold stream process. This process is based on impact phenomenon caused by impingement of high velocity particles against a cemented forward plate. The unit consists of a feed container, a compressor capable of producing high velocity stream of air operating at 7 megapascals, a target plate made of cemented tungsten carbide and for producing impact, a classifying chamber lined with uh, tungsten, while the supersonic nozzles and the target generally are made of cemented tungsten carbide. The tungsten carbide. Mechanism of the process quickly, I will just complete this. Just only 3 minutes left out for me. The material to be powdered is fed in the chamber and from there falls in front of a high velocity stream. This here causes the impingement of material against a target plate where material due to impaction is shattered into the powder form. This powder is sucked and is classified in the classifying chamber. Oversize is recycled and fine powder is removed from the discharge chamber. Rapidly expanding gases leaving the nozzle create a strong cooling effect to the adiabatic expansion. This effect is greater than the heat produced by the pulverization. This mechanism of this process is like this. The material which needs to be powdered is being fed to the chamber and there falls in front of a high velocity stream of air. This air causes in the impingement of material against a target plate. So once the material has been fed to the chamber and it is been subjected for a high velocity stream of air, this high velocity stream of air, once it impinges, it will go into break over the target plate where the material due to impaction is shattered into the powder form. So material has been impacted by means of a high velocity stream of air and this material will going to fall over the target plate once it shatters. Once it shatters over the target plate, it will get converted into the powder form. Now this powder is sucked and it has been classified in the classifying chamber. Oversize is recycled and fine powder is removed from the discharge area. So rapidly expanding gases leaving the nozzle create a strong cooling effect to the adiabatic expansion. This effect is greater than the heat produced by pulverization. So these are the techniques I wanted to discuss in today's class. So other techniques are there, the chemical methods and all those things. So I will come back to this things in the next classes next week. So for any clarification, anybody is having any clarification, you can talk to me. Last 1 minute left for me. If you have any clarification, the material has been already uploaded in the Google Classroom for this chapter. You can get it. Okay. Any clarification, guys? You can refer to the Google Classroom to get the notes or a course material. It's already been uploaded there. You can get that. And if any clarification, we'll discuss in the next class. And it's already time is running out for me. Okay.